Hi, I'm Joe Hupsey, and I'm here with Scott Meeth, the presenter of the paper Methods and Verification IP for Formally Verifying AMBA 4 ACE and AMBA 5 CHI Cache-Coherent Designs. Scott, before we talk about the paper, maybe just give a little bit of information about yourself.
I've been in the business for 17 years, the verification business. I started at Sun. I worked there for about 13 or 14 years. And the last 3 years, I worked in processors and ASICs and SIM informal. So almost a full range of hardware, really. And the last 3 years, I've been working in Jasper doing formal, tuned VIP and methodology and almost exclusively ARM protocols.
Terrific. Now, what's the number one issue people need to keep in mind when they're verifying ACE designs?
The nastiest thing I found, and it's very clear in my mind, is the Snoop channel. It was added, the Snoop interface was added to ACE from AXI4 to facilitate the hardware maintenance of cache coherence. And it seems simple enough, it's Snoop request, but the Snoop response and Snoop data are separate, and that has introduced surprisingly complicated complexity in trying to keep the three of them in sync.
Interesting. Now, what are the advantages using formal verification, using that approach for verifying such designs?
This problem is particularly well suited to it. The formal verification tools give you the aggressive attempt to falsify your properties, and that gives you good breadth of coverage, which you really need to be able to flush out all the corner cases that can go wrong in a coherence environment. A coherence bug normally, I guess there are some deep ones, but there are plenty of shallow ones that you want to be able to flesh out by aggressive breadth first exhaustive search, and that's what Formal gives you.
Makes sense, makes sense. Now, the paper talks about an intelligent proof kit, so a bundle of assertion-based verification IP. Tell me, what's the advantage of that approach versus, say, other verification solutions?
First of all, there's two proof kit for ACE two proof kits that we have, and the one is an interface proof kit that is just connects to a single interface. Okay. This one was correlated and developed in sync with ARM, independently, but in sync with ARM, and verified to be functionally equivalent, and also tuned for formal. Okay. Theirs is more tuned for SIM, ours is for formal, and tuned to be performance informal and also to be configurable and to have the non-determinism that you need to use formal effectively. The system proof kit also has, it's a table-based approach, so it has a row of a table for every architecturally significant event in the protocol, which gives you a full specification of the protocol and a cover for every event. Okay. And also a handy way, if you have to modify this thing, and you probably will, to be able to generate automatically the code from the tables, and so you can maintain the tables. So that's off the top of my head. Well,
you also touched on it in your talk, some unique debug capabilities as well.
Right. We each of them also has some utility signals that help you when debugging things. For example, if you have a response come and you want to see clearly which address stage it goes with, what was the address for it, and some of the other control information that comes with the address. So there's a signal that just tracks that information for you and spits it out for you when you want it.
Great. Well, thanks, Scott, for taking time to share your insights.
Thank you so much, Joe.